Good morning, ladies and gentlemen, and welcome to the C 2022. This is the last day of the conference, and I'm very happy to see many of you who are on site, and also we have many online for the Zoom and also the Facebook. So I would like to welcome all of you again, and as Ms. Bill already introduced to you that we have three interesting presentations today from the three well-known experts from Thailand and Australia and also from France. So I'm very excited to hear about the keynote lectures, and I think so are all of you. So again, I would like to say that this session will feature the three well-known experts from Thailand, from Australia, and from France, who come to share their experience and thoughts on how the science, technology, and innovation can contribute to the sustainable energy and environment, and also the net zero emission target. Yes. And so without further ado, I would like to start to invite our first speaker, Professor Shabbir Gheewala. And I would like to briefly introduce him. He's a professor at the Joint Graduate School of Energy and Environment from Thailand. And he teaches life cycle assessment and led the life cycle assessment laboratory for over 20 years. So he has so many graduates, so you can see also his biography from outside. And he also holds an adjunct professorship at University of North Carolina, Chapel Hill in USA, and his research focuses on sustainability assessment of energy systems, sustainability indicators, circular economy, and certification issues in biofuels and agro industry. He's a national expert on life cycle inventory as well as carbon and water footprint in Thailand. He mentors a lot of research network on, of course, on the sustainability assessment and policy for food, fuel, climate change in Thailand. And he got so many awards, so he ranked top scientists by many institutes. And more recently, he has been awarded the Mahidol Science, Environment and Sustainability Award just this year. So he published 300 papers in peer-reviewed journals, and he is also the editor-in-chief of many journals, including the Sustainable Energy and Environment, Frontier in Sustainability, and Sustainable Production and Consumption, which is very related to what he's going to talk today, and also Life Cycle Assessment, and also other international journals. Yeah, so this is his keynote lecture of sustainability and for transitivity, doing more to know by less. I think all of you would also interested to know as well. So, ladies and gentlemen, please welcome Professor Shabbir Gheewala.
Thank you very much for the kind introduction, Ajahn Sunirat, and thanks first of all to the Joint Graduate School to invite me today for this talk. Especially, I would like to thank my dear friend and colleague, Dr. Sebastian Bonnet, who has been very instrumental in inviting me, and he is the engine behind the conference, and many of these conferences, including this one. So I'd like to thank him especially. He's here. Please raise your hand. You have been a bit invisible, so I would like to thank you. So with the COP27 going on in Egypt, and now we are talking about sustainable consumption and production and carbon neutrality. So my talk is going to be a bit different from what many might expect. It is not about many figures or many laboratory experiments and so on. That's not what I would like to talk about today. But I would like to talk about worldviews, about how we need to change our way of thinking if we have to achieve this so-called carbon neutrality and so on, and what we can and should possibly do to achieve that. If I can get the slide to move. Hold on. Okay. First things first. We have to switch on this before it moves. So, here I have just put this from a new report that was published quite recently by the UNEP. These are some of the top greenhouse gas emissions emitting countries in the world. So, you see here we have China, USA, India, EU 27, Indonesia, Russia, and Brazil. So these are kind of, along with international transport, these countries account for more than half, about 55% of the worldwide greenhouse gas emissions in the year 2020. You see just these countries, yeah? And of course, these are total emissions, so this takes into account the number of people that are there. So, okay, China has a lot more people than China and India have a lot more people than, for example, maybe Brazil or something like that. Maybe Brazil is also quite long. But let's see. So if we look at the per capita emissions, still we have kind of the same countries more or less, but now things have changed. So you have USA as the highest one. So if you look at the world one, so that is about 6.3 tons of carbon dioxide equivalent per capita, and USA is more than twice that world average, and Russia is also not very far behind, and then you have China. There you can see that India is trailing because the population is large, even though the total greenhouse gas emissions were rather large as well. But this is what we are worried about, because when these countries which are having lower per capita emissions, and if they start to have the same level of what we call development, and they start to increase their greenhouse gas emissions as well, what will then happen? So that is something that we have to think about, and think about very carefully and very quickly, because we don't have that much time remaining. So here you can see that these are some of the current status along with the trajectories of the greenhouse gas emissions and the targets, and where we are doing, how we are doing with respect to the targets. So you can see that for China, India, Russia, Indonesia, and even Brazil, we are not moving so much towards the, at least for the first three, China, India, and Russia, they're not even moving in the direction of the target as of now, okay? And this is based on the nationally determined contributions that have been promised, yeah? Indonesia seems to be at least not going in the opposite direction in Indonesia and Brazil, but USA and EU apparently are somehow kind of moving towards the net zero targets. So you can see that there is a lot that still needs to be done. And this will not require these so-called nudges or, you know, let's do things carefully. I think a drastic change is required. And this drastic change is not going to come only from technology, and I will talk about it a lot, but from a total perspective change, okay? Now, before I move further with the greenhouse gas emissions, I would like to say that looking at greenhouse gas emissions in isolation is not a very smart move. And you can see that many years ago, a group of scientists, they set these so-called planetary boundaries. They looked at what are the safe limits of certain areas that we want to protect, and within which we should be if we are to be sustainable. Sustainable in the sense of if we want to continue living our life. Yeah? And this was in 2015. This paper was published in Science. And back then itself, you can see that climate change is in the yellow zone, which is the high-risk zone. Biodiversity is in the red zone. Biochemical flows of phosphorus and nitrogen are in the red zone. Land use change is in the yellow zone. Water seems to be in the green zone, but you know the problem with water is not that we don't have enough of it. We have, if you just look at the total amount of water in the world, the fresh water, it is more than what we need, much, much more than what we need. However, the problem is that we don't have enough of it where we need it and when we need it. The problem is of spatial and temporal distribution, which is not very equitable. And climate change is only going to make it worse. Okay, apart from the red and so on, what I want to show and point out over here is that all these impacts are related. So land use change is related to climate change, water use is related to climate change and to the land use. Biochemical flows are related again to land use, for agriculture, for example, with fertilizer use, etc. So biodiversity is again related to that when we are producing these chemicals and releasing them into the environment. So all these impacts are actually related. So when we talk about all these things together, there's a holistic view. And that is something that I want to emphasize over here, that if we try to look at only greenhouse gas emissions and try to solve that problem, we will be in trouble still, even though we are not even solving the greenhouse gas problem yet. Okay? So this is what I would like to call as wicked problems. Okay? Wicked problems. I think many of you are familiar with this term of wicked problems, and wicked problems cannot be solved in the way that we are looking at them now. And this is something that is very, very important, and I will come to this point again during the talk today. So in 1972, actually, this report by the Club of Rome was produced, Limits to Growth, it was called. This book that I have presented over here is the 50-year update of that Limits to Growth report that was first published in 1972. So in 2022, they came up with they had a 30-year update and then a 40-year update, and now they have a 50-year update. And even though the limits to growth at first was very much, it became a shock for society, and then the economists came and then they destroyed the report, rightly or wrongly, using all kinds of arguments. They said that this is bullshit. We are, you know, we have survived so far and we will continue surviving. We will always find a way out, just like we have found out a way in the past. But here I would like to give the analogy of an aeroplane, you know, an aeroplane that is crashing, and that's us. Okay? So you may say that the aeroplane is crashing, but you don't look at the crashing, but you say we are still in the air because we have not touched the ground yet. We are in the air. What's the problem? But you are crashing. And that is the issue. And we cannot experiment and wait till we crash. And then let's say, yes, of course, it was right. No, we don't have that luxury. Yeah? And okay, in 1972, a group of very smart scientists from MIT, they used system dynamics to model the Earth. Okay, their model might have been not that sophisticated. You can always, you see, models are always wrong. As the great modeler Box said, you know, models are always wrong, but some are useful. Yeah? So, yes, their model might not have been very sophisticated, but they got the main points right, because much more sophisticated models with much more sophisticated computing tools in the last 50 years were developed, but their main points that they said still remain, you see. So here you can see economic growth and the use of physical resources are coupled, they're tightly linked. And decoupling, we keep talking about decoupling, and I will talk about it more again. This decoupling is a mirage, okay? It's a myth. We will see with some very simple numbers why it doesn't work. And again, there are, first they said, okay, we have to decouple. But the underlying philosophy in decoupling is that we must keep growing. So we keep growing, but we decouple the environmental impacts from the economic growth. So we can keep growing economically, but the environmental impacts will reduce. And there are two kinds of decoupling: relative decoupling and absolute decoupling. So first we started with relative decoupling, then we said absolute decoupling, but in reality, it is impossible to keep growing continually and infinitely. And nobody wants to talk about that because that has become our mantra, yeah? GDP, let's focus on GDP, yeah? And this has been a very big problem with us. And efficiency, that's another thing that I want to point out. We keep talking about decoupling and efficiency. Efficiency is good, but it is not the panacea for all the ills, okay? Because with efficiency comes overshoot. And that is what was predicted back then. And that is what we have seen in history. 200 years ago, Mr. Jevons, you know, the guy with the Jevons paradox, he looked at the use of coal, and as the use of coal became more efficient, instead of the use of coal declining, the use of coal actually increased. Because as it became more efficient, it became more cheap, we expanded the applications of it, and we started to use more. And that is always what happens. So efficiency always gets confounded with overshoot. So I'm not saying efficiency is bad. I'm not saying that we should not aim for efficiency. Of course we should. That's a smart thing to do. But that is only one side of the coin. That is not going to solve the entire problem. And this is, it has been seen. If we want to open our eyes, we have our eyes wide shut. If you want to open our eyes, you will see that. Another thing is about this growth. Why we are so obsessed, we are fixated with growth. And here you can see the myth of decoupling by this very famous professor from the University of Surrey. And he's showing this here. Sorry for the guys who are on the Zoom, they cannot see me pointing, but please imagine the first bar, which shows the greenhouse gas emissions as of 2017 or something like that. We are at around 500 grams of CO2 equivalents per 2010 dollar. And then, if you want to have absolute decoupling, and we want people to improve their economic growth at the same time, we would have to reduce from 500 grams CO2 per dollar to 2 grams. You see the last one. 2 grams. So that's almost 250 times reduction of our efficiency, our carbon intensity. Now let's talk. Do you think it's possible? And we keep growing economically. We let all countries grow economic, GDP grow and economic growth and focus on that. Do you think it is possible? I am not saying that we don't need GDP to grow, but that cannot be the sole criterion. And it is not always necessary that GDP growth is the panacea. This is actually what they call neoliberal economics, where they say that, okay, if you let people get richer, then one part of society gets richer, very rich, and then there'll be a trickle-down effect. And then the whole society will move up and get richer. But experience, history has shown us that doesn't happen. Only the inequality increases. So now we are talking about equity. But this model of growth that we have been promoting so far has not helped to reduce the inequity. Even the rich countries, the so-called very developed countries, even they have very high level of inequity. So this is not going to solve the problem. And we are very afraid of not growing. If I say, okay, let's not grow, people think, oh, shall we go back to the Stone Age? Oh, or shall we live in a trailer like a hippie, you know, with very little belongings? I don't want that for my family. But actually, in reality, growth is, you can have a good life, without necessarily having this kind of growth that we are promoting, this kind of consumerism we are promoting. It doesn't have, you don't have to go back to the Stone Age, and you don't have to become a hippie living in a trailer, okay? So, but this is the thing that we have about growth, and this is what stops us from pursuing other things. And every government is talking about GDP growth. Every government, you see? So where are we then? So there are economists, this famous economist from Oxford University, Kate Raworth, she has come up with this donut economics. So she has combined the idea of the planetary boundaries as the kind of upper threshold. Yeah, here you see the ecological ceiling. And then below that is the social foundation. So you don't want to go above the ecological ceiling, and you don't want to go below the social foundation, because you want people to have a good life. You want them to have proper food, nutrition, health, energy. You want to have them. It's not like we don't want to have them. So we have this sweet zone, literally, sweet zone in the donut, yeah, in between this, where you are having a good social life. At the same time, you are not exceeding the planetary boundaries. Is that possible? We have to try. What does she say? How can we approach that? She has not found the final solution, but these are the 7 ways that she has proposed. For example, the first thing that I've been talking about just a little while ago is our fixation with GDP. And we have to keep GDP increasing exponentially and continually and forever. But actually, we can transform that into this donut. The other is, we have to see the big picture. So here, you see, we think of ourselves as separated from nature, but we are actually part of nature. All our economic models, etc., use nature as just something that has to be used. But it is actually natural capital. So we cannot sell our capital and call that a profit, right? But in economics, natural capital does not form a part of the financial calculations. So then we are selling our capital and we are calling it a profit, which is why the problem, because we don't consider ourselves as part of that. And then human nature. We have defined this theory about man being very rational and only very selfish and working for our own purpose. And all models are based on that. However, it doesn't have to be that way. Man is not like that. Actually, we are social beings and we do care for others, and our models should also include that. And systems. Economic theory tried to become scientific by making models that look like science. Economics is actually not really a science, it's an art. But it has become a science by making these kind of models and making these equations and supply, demand, equilibrium. And then when nothing works, we call it market failure. But market failure is what always happens, yeah? But actually, our systems are wicked systems, yeah? So we have to look at the dynamic complexity. That is very important. That is something that we are missing. And that's what the Limits to Growth team did. They used systems dynamics to make the models. So that modeling is very important when we want to make models. And here, we think that, what I mentioned before, that we think that, okay, we let one part of society get richer, and then there'll be a trickle-down effect. And then everybody, but that doesn't happen. This so-called Kuznets curve, it doesn't happen. No, what we need to do is distributive by design. Our design should be such that we are already having equitable distribution of wealth. Wealth is not being, it's not only about money. Wealth is not the same as money, yeah? So we are talking about distribution of wealth. The means to create money, not money itself. And yeah, create to regenerate. Here also we think that, okay, if we get richer and richer, we will be able to solve our environmental problems. As you know, in developed countries, first they got very polluted and then they became okay. It's not quite that when you look at the details. So this Kuznets curves also doesn't work really. And we have to be regenerative by design. Why create a mess and then say that we will clean it up later on? Why don't we create our design in such a way that we don't have to have a mess in the first place? And it can be done. It can be done. And the other is this, our addiction with growth. Do we always have to grow? Is growth always a good thing? So this is something that we have to think about. It's a bit philosophical as well, but it is also very important for us to consider. So here, I just give you an example. Yesterday there was a discussion, my colleague over there, she talked about harvesting, mechanical harvesting, and we were having a discussion that, you know, we have studied about this harvesting problem. We know that green harvesting of sugarcane is good, and if you burn before harvesting, then it creates PM 2.5, etc. You talk to farmers. We have also talked to farmers. We have talked to hundreds of farmers. And the problem is, it's not because we have different perspectives. Wicked problems means having different perspectives to look at different value systems, different worldviews, different interests and conflicts, etc. So this is one of my colleagues. He also was once upon a time my student as well. But he has been doing this mind map by studying a lot of socioeconomics on the field. And this, you see, this is just an example of how intricate this whole problem is, though it looks very simple. Of course, if you don't burn the sugarcane before harvesting, you can use the cane trash for energy. Yeah, we know that. 20 years we've been saying that. So why is it not happening? It's so simple, right? Just don't burn. You have mechanical harvesters, so why doesn't it work? Because there are many other things in between. There are layers, and there are other problems. For example, the sugarcane farmers, their priority is not PM 2.5. They don't even think that they are the problem. They create the problem with 2.5, PM 2.5, or they are the ones who are responsible for it. They think that there are many other causes of PM 2.5, not only us, something like that, or not us at all. And their problem is how to get the sugarcane to the sugar mill on time. There's a big queue over there, the thing might get spoiled, they may not get enough returns, so on. So all these things are very interrelated. And this is something that we have been working on and trying to solve in this, what we call the wicked problem, yeah? Looking at the complexity, the dynamic nature, and the interaction between the various perspectives of different stakeholders and many other things. So yeah, so this again I've just looked at, I will not go too much into details. I think there are many speakers yesterday and the day before also who talked about this, that okay, I mean there are many perspectives here. I took just businesses and citizens in terms of sustainable production and citizens in terms of sustainable consumption, that what we should do, yeah, and what we can do, something like that. But this is not the main point, yeah, but I mean, this is of course very important, but it is only one thing. And then, yeah, okay, we have to, there's lock-in that we try to avoid, you know. Once we build a coal-fired power plant, it's going to last for 45 years maybe. A cement plant is going to last for 40 years. A building is going to last for 100 years or 80 years, something like that. So we cannot have this, you know, we cannot, once we invest in that, then we can't change it. So that these are the lock-ins that we have to prevent, yeah. Another big system is the food system, which is responsible for about 1/3 of the greenhouse gas emissions, yeah. And to reduce that, okay, we know that there are many things, but they require lifestyle changes. For example, moving towards a vegan diet or something like this. I'm not saying that everybody must become a vegetarian. It's not like that. But we do have to consider it. Maybe we have to reduce something. I don't promote extremism. That is something that I want to say. But these are the kind of things that we will have to consider. And now, we don't have enough time left for doing further. So absolute sustainability is something that we have to consider that's related to those planetary boundaries. And this is something that we have also been working on at our institute on absolute sustainability. And here, if you see, if we allow business as usual, then all these impacts from the food systems are going to rise by 60 to 90% by 2050. How to bring them down to the level of, so there are ways. So you see a lot of it is depending on lifestyles, which is the green bar, and the yellow bar is the food loss and waste, which is very high. In worldwide, the food loss and waste is about 30%, yeah? So if you think that in developing countries it would not be, but it is so. Even in developing countries, the food loss and waste is very high. So these are the things that we will have to consider. Here you see, you have the food pyramid and the environmental pyramid, and they're exactly opposite, and they fit very well. So if you want nutrition, better nutrition, and a lower carbon footprint, it can be done at the same time. And this is what this graph is telling you. I would love to discuss details, but okay, the time is kind of short, so I will not go into the details, but maybe in the question and answer session or something we can talk more about it if somebody is interested. But these are important, yeah? So we have been looking at biorefineries, how to utilize biomass. So when you look at palm, for example, somebody is smiling. When you look at palm, the oil is only 17 to 20% of the fruit, and the fruit is a very small part of the tree. So if we look at only the oil and focus on that, we are wasting a lot of the biomass. So this is the idea, the conceptual idea behind a biorefinery. We try to use everything and try to produce value-added products from that. And so we have biofuels, biomaterials, biochemicals, everything coming out. We have done, recently we have concluded a project and shown how a palm biorefinery can work. In the past, we've also worked on sugarcane biorefinery and shown that how it can work. And same idea with biofuels, biomaterials, biochemicals, everything being produced from the sugarcane biorefinery. So last few words on circular economy. We think of the life cycle and then we think that, okay, that's circular. It looks like a cycle, but actually something is missing. This part is missing. The one from the end of life to the extraction is missing in reality. And that is why it's not, even though it looks like a cycle, it's actually linear. It is not a circle. So how to fill that? And that can be either by recycling materials. We focus a lot of times, people confuse circular economy is the same as recycling materials. No, recycling materials is one part of circular economy, but it is not even the best part. But it's of course better than throwing it into the landfill. But there are many things that you can do to do more with less, as we said. And these are through all these things: reuse, repair, refurbish, remanufacture, many things. But this will require a change in the business model. Our current business model is based on selling more. The more product I sell, the more business I do, the more profit I make. Now if I say that, hey, you should not sell more, people say, how come? That challenges my thing, you know. It's against my interest. So that means we need to change the business model. But changing that business model means changing the ownership. So the owner of the good that is produced is not the user, but the producer. Now this is a very interesting story, but I'm running short of time. So, but please, if you want to discuss this more, we can use the question and answer session to discuss more about this. This is very, very important. So let me these behavioral changes, you know, how can we make behavioral changes in society? So some people have come up with these things, you know. So you have psychological needs and our biases, our habits, or heuristics, all these things need to be taken into account. And I will not go into the details for now, but this is very, very essential. Otherwise, if you just think somebody somewhere will develop some technology to solve the problem, it is there, but it's not going to solve the entire problem. So with that, I would just like to conclude that wicked problems need holistic thinking and system solutions. We are not going to solve them with a linear way in which we have been doing this with a reductionist approach. It's not going to work. And I would say mindfulness is very important, better than tokenism. You know, if you can buy one coffee, that mug that you reuse and then say, I've done for the environment, but then you're driving a big car, yeah? Or you're going business class all over the world 5 times a year. But then you have a cloth bag that says, you see, say no to plastic. So that is tokenism, okay? And being mindful about what you do. I don't carry this glass with me every time because I drink coffee outside once in 2 weeks maybe. So I don't think it's necessary for me. I can use a disposable cup, it's all right. Doesn't matter. But if I was drinking coffee twice a day from outside, I should carry that, yeah? So this kind of thinking has to be there. We have to think. And that's why I talk about environmental pragmatism. That is more important than environmental extremism. Say no to plastic. Ban plastic. No, plastics have their own use. That is why they are there. So we have to be careful about what we want to do. And we have to find replacements, good replacements. Are bioplastics really replacements of plastics? There are problems with bioplastics as well, no matter what we like to say. So I think we have to be reasonable, yeah? And finally, yes, sustainable consumption is absolutely a must. Sustainable production is important, but it is only one side of the story. Without sustainable consumption, sustainable production will not work because we have to solve the conundrum of growth And efficiency is always confounded by overshoot. So I think I have run out of my time. So I had some other things to say as well, but some other time. So how am I doing with time? Is it okay?
Hello. Ka. So you use exactly 30 minutes.
Thank
Very
you.
good timekeeping. Thank you very much.
Thank you.
Okay. So thank you for a very enlightening talk. And Professor Shabbir emphasized a lot on the importance of sustainability towards the transition to carbon neutrality and the interrelation between stakeholders and consequent impact along the supply chain must be considered. And one thing I think is a key message is also the create by design. And I think this is the answer for the doing more with less, right? And he also gave an example of circular economy. But it needs the change of the business model. Yes, so owner can become user or producer or something. Yes, so I think this is a very interesting presentation. And due to the lack of time, maybe I will ask all the questions to be at the Q&A session. Okay, so ladies and gentlemen, please join me to give an applause again to Professor Shabbir.